Alright, so for this lesson we'll take a look at the associative property and the commutative property. And a nice way to remember which one is which is using COAG, C-O-A-G. The C stands for the commutative property, okay? And the O tells you that the order doesn't matter with the commutative property. For example, you can have 2 plus 3 on the left hand side, which equals 3 plus 2, right? So you switch the order on the right hand side, and 2 plus 3 on the left is equal to 5, and on the right 3 plus 2 is also equal to 5. Right, now let's take a look at the associative property, which is the A. And that tells you that grouping doesn't matter. So it goes with the G. So for example, let's say I have 1 plus 3 plus 4, and the order didn't change, so we'll keep it as 1 plus 3 plus 4, but we're going to group them differently using parentheses. So I'll group the first one, put parentheses around the 1 plus 3, and I'll put the parentheses around 3 plus 4 for the second one. Okay, now let's see what we have. On top we have 1 plus 3, which gives you 4, and then 4 plus 4 gives you 8. For the second one, you have to do 3 plus 4 first, which is 7, and 1 plus 7 is also 8. Right? This shows you that grouping them didn't matter. They both equal 8. Now let's take a look at another example illustrating the properties. Again, let's think back to COAG. Remember, the C is the commutative property and the A is the associative property. So here's the other example. Let's say we have A plus B plus C, and that's equal to B plus A plus C. So we switch the order of the letters, alright, from the left hand side to the right hand side. And which property illustrates that the left hand side is equal to the right hand side? Which property shows you that the order doesn't matter? It's the co-component, so CO. So the commutative property shows us that the left hand side is equal to the right hand side. Okay, and you can plug in numbers for A, B, and C, and you can justify that conclusion. Alright, let's take another look at a different example. Let's say we have A plus B plus C, keeping the order the same. Again, the right hand side will be A plus B plus C also, but we're going to group them differently. So on the left hand side I'll group the B plus C, and on the right hand side I'll group the A plus B. And again, if you were to plug in numbers for the left hand side, and same thing for the right hand side, and you're going to get the same answer regardless of how you group the letters. This also works for multiplication. Right? So let's see how that works for multiplication. Let's say we have 2 times 3 times 4 on the left hand side, which equals 3 times 2 times 4. So I switched the order of the 2 and the 3. Right? When going from the left hand side to the right hand side. So we were to do it out according to PEMDAS, it's just multiplication, so we'll just carry it out from left to right. On the left hand side, 2 times 3 is 6, and then times 4 gives you 24. And on the right hand side, again it's PEMDAS, just from left to right because they're all multiplication. 3 times 2 is also 6 times the 4, which is 24. Right? So the left hand side is 24, the right hand side is 24, and which property illustrates that the ordering doesn't matter? So if you think back to coag, it's the commutative property. Alright. Alright, let's take another example. Again, let's think back to coag. It's a nice way to remember which property is which. So again, let's take this example, 2 times 3 times 4 on the left hand side. Let's keep the order the same, so 2 times 3 times 4 as well on the right hand side. But we're going to group the left hand side with putting the parentheses on the 2 times 3, and on the right hand side we'll put it around the 3 times 4. So 2 times 3 is 6 times 4, which is 24 on the left hand side. On the right hand side, you have to do the 3 times 4 first, which is 3 times 4 is 12 times the 2. Now 2 times 12 gives you 24 also. Right? So 24 on the right, 24 on the left. So which property illustrates that grouping doesn't matter? That goes with the AG, coag. So that's the associative property.